So let's see how you're doing with this. So for the first one here, to find z, of course, we could just do a squared plus b squared equals c squared, right? So z would be, and I'm just going to write this out shorthand, the square root of 17 squared minus 8 squared. Does everybody see why we're subtracting there? Because it'd be z squared plus 8 squared equals 17 squared, then you have to subtract it. So you come up with what for z? 15 inches. Very good. Now for x and y, we're going to have to use trig functions. So let's look for angle x first. Of course, the 17 here is the hypotenuse. 8 is one of the legs. Now, why am I using 8 instead of the 15? Well, because we were given the 8. I know that's correct. The 15 we just calculated ourselves, and there's a chance we made a mistake. So I always try, if I can, to go back to original information that was given. So the 8 is the opposite side according to angle x. So I have opposite and hypotenuse, which is sine. So I will fill in what I know. Do I know the angle? Nope, that's what I'm looking for. Do I know the opposite? I better. That was the 8, right? And the hypotenuse is the 17. Now, when I am looking for an angle, how do I solve the equation? Inverse. So it is second sine 8 divided by 17, close the parentheses, and I get 28.07 degrees. Now I could go and do an inverse cosine for y, but I'm just going to go ahead and take 90 minus 28.07, get 61.93. Why did I use 90 instead of 180? Well, because this is already 90, so 180 minus 90 leaves me with 90 for the other two. How many of you had those two angles, 28.07 and 61.93, and the 15? 61.92?
You didn't round up the 3 digits.
Oh, yeah.
Yep. Because it would have been 928 or 927. So down here, what'd you guys get for x? 37. That's just subtracting from 90. The 53, 90 minus 53. Y and z are going to take a little more work. So I have the 53. I'm going to go with that angle. According to the 53, I got the 12, which is the adjacent leg. If I'm looking for y, that is the opposite leg. So now tangent deals with opposite and adjacent. And yes, I always write down the definition first. I'm not going to take off points if you don't, but it saves so many mistakes. So now in this case, I do know the angle. It's 53 degrees. The opposite side is y. That's what I'm looking for. And I have the 12 centimeters. When I am looking for a side, I put this over 1 so it's a proportion so I can cross, multiply, and divide. So it's tangent of 53 times 12 divided by 1. Give me 15.92. 15.925, I guess I'll go. This is 15.925. How many of you had 15.925? Well, here then, what'd you get for Z?
19.94.
19.94 sound right? Then you just do a squared plus b squared equals c squared. Or you could have done cosine of 53 degrees equals 12 over z. Could have solved it that way. Come up with the same thing. Find x for me. So to start this one off, what's the first thing we want to do?
Find underneath that circle.
Yes, find from here to here, right? So to do that, we got to put in our radii. We know they're going to form right angles with that tangent. Then we're going to cut it down here. So now we're going to take a better look at this triangle. We know that's a right angle. We know this here is 0.400. How do we know that? Half the diameter. Very good. What's this angle down here? 35 degrees. And we're looking for this dimension there. I'm just going to call that A for now. So what I have, A is the hypotenuse, and this is, according to my angle of 35 degrees, is the opposite side, which is the sine. Sine of an angle is opposite over hypotenuse. Filling in my angle, 35 degrees. Opposite side is 0.400. We are looking for the hypotenuse. So now we have 1 times 0.4 divided by sine of 35 degrees. 0.6974 inches. Now you might be wondering, why did I go to 4 decimal places there instead of 3? Well, one is the machining application, so the 10,000th is common. But if I want my final answer to 3 decimal places, I got to carry my work to at least 4 as I'm going through here, so I avoid some major round-off errors. So now I've got the 0.8, I got the 0.6, and this, of course, is also 0.400. So I'm just going to add those up. 0.4 plus 0.8 plus my previous answer. 1.8974 total. So how far does that extend up above here? Well, I take this minus this, which gives me 0.0974. If you had just 0.097, that'd be acceptable. How many of you had that? How many of you are getting there, just need a few more minutes? How many have no clue where that came from?
A few minutes.
A lot of minutes? You guys said you have 5-inch sign bars or 10-inch sign bars on the shop?
I know I've seen it up in going on. My guess is 5.
5. We'll stay with 5-inch sign bar. Okay, we want this sign bar to create a 28-degree 40-minute angle with the horizontal. Find the gauge block buildup. Just find the height of the gauge blocks needed to create that angle. So obviously we're using the sine here because it's a sine bar. So when we put stuff in this, where do we put what? Well, we know the angle. Has to be 28 degrees, 40 minutes. It'll be x over 5. So we'll put this in over 1. Now, depending on your calculator, it might be easier to enter this one or another. A lot of times will just do 28 plus 40 over 60 and close the parentheses. But I'll do this the right way this time. Oops, wrong one. So there, 28 degrees, 40 minutes. Like I said, a lot of times I just take a shortcut, do 28 plus 40 over 60 is the same thing. This is going to be times 5 divided by 1, giving us that x is 2.3986. How many of you had that? Do you know how to get it?
What do you mean 40 over 6? How do you enter like 40 slash 60?
I would just do this. Sine 28 plus 40 divided by 60, close parentheses, just like that. Yeah, on yours you won't. On yours it'll actually show the degree symbol twice, but it is minutes. It's just showing the different symbol. Yeah, yeah. My calculator's a little different that way. Yeah, I know it can be. Yes, I know. We're really stretching my artistic abilities here today. Similar to it, just one end though. Tensile, not tinsel.
Beer funnel upside down.
Anybody want to guess what we're going to try to find? That angle. Taper angle. Okay, so first of all, what do we get for this dimension array here? What's that? 1.875? That sounds about right. We have the 4.5. Oops, I don't know where that 7 came from. Crap. Minus the 0.750 is 3.750. Divided by 2 is 1.875. Or you could have divided each of these by 2 first and then subtracted. I want to give you the same answer. So what we have is this triangle right here. 1.875 and 2.5, and we're looking for this angle. That is going to be a tangent of our angle equals the opposite over the adjacent, and we're going to do an inverse tangent. So that our angle equals 36.87 degrees. How many of you got 36.87? Good deal. One last one for you to try. Pretend those are evenly spaced holes around what we're also going to pretend is a circle. Diameter of our circle is 6 inches. Find the center distance from one hole to the next. 7 of them around there, yep. So first thing we're going to do Drawing the radii to the center of the circle. We know that is 3 inches. We need to know this angle. How are we going to find that angle? 360 divided by 7, which is going to give us 51.4285714 degrees, correct?
I didn't mind it.
Did yours different?
Probably.
Okay. Is that what you guys come up with when you divide by 7? Yeah, 4-3. The reason I left it like this is because now I'm going to divide it by 2 to get this angle. So when I divide that by 2, I'm going to get 25.714 degrees. So 25.71 degrees. So now what I have, I'm going to redraw this triangle here. This is 25.71 degrees. This is 3 inches. I can find this side. Of course, that is the opposite side according to our angle, so we are dealing with a sine. So we will plug in our angle, 25.71 degrees. The opposite side is what we're looking for over the 3 inches. So we're going to have sine of 25.71 times 3 divided by 1, giving us 77 point... Oops, I didn't get the sign in there. $1.301. You got it. Now I'm going to leave that in the calculator because I do have to double that because that's only half of that distance. So times 2. So 1.603 it looks like, or 6029, however you want to round it. 2.603 we're going to call it for now. Any questions on those? Good news. There's no homework for tomorrow. Bad news. I'm giving you a quiz to take home.
Oh, take home. That's not bad.
You got 4 minutes to get started on it now, and then we'll take it home.